Hey everyone, I hope you liked this brief introduction to machine learning. The goal was to present to you this very interesting topic and help you take your first steps on it. If you liked the previous videos, you might be asking yourself, what's next? What else should I learn in the field of machine learning? So in this video, I'm going to give you a few directions. First, it is important to understand the difference between supervised and unsupervised machine learning. What we've learned so far in the course is supervised machine learning. In this type, we train the computer with observations and the actual answers. So taking the example of the iris dataset, we have 150 observations, and for each of them, we know which is the species. So this is how the computer learns. After training, when the computer sees a new observation, it is capable of classifying it into one of the groups or species. On the other hand, in unsupervised machine learning, we don't have answers. We just give the computer a bunch of data, and what does the computer do with it? Well, one of the things the computer can do in unsupervised machine learning is clustering. Here, the computer creates groups with the data. So still using the iris dataset as an example, let's say we didn't have the target group, which are the answers. Let's say we only had the measurements and we would like to understand more about the 150 samples of flowers we have. The computer could then learn from the data and tell us that by looking at all those measurements, it could form 3 clusters, which could help us understand that we might be dealing with 3 different species. Clustering is commonly applied to other areas like marketing for customer segmentation, in insurance for fraud detection, and many other areas. Some popular algorithms for this kind of machine learning are k-means, affinity propagation, optics, spectral clustering, BERT, and DB-scan. Another thing we can do in unsupervised machine learning is association. One common knowledge we can acquire with this method is, for example, a customer that buys product A also tends to buy product B, so we try to find association with our data. Some popular algorithms for this kind of machine learning are a priori, ECLAT, and FP growth. Now, going back to supervised machine learning, it's important to learn the difference between classification and regression. Let's start with classification, which is commonly called categoric predictions. With the iris dataset, we had a classification problem. For new observations, we wanted to classify them into one of the species we had. There is also a very cool example of this kind of classification using the digits dataset, which also comes natively with scikit-learn if you want to explore it. In this example, we trained a computer with data of handwritten digits. So we have 10 digits from 0 to 9, and when we give the computer a new observation, it classifies it into one of the groups we have. This is a very cool classification problem. During the course, we use KNN and logistic regression. Other popular statistical models for this kind of problem, or we can call them algorithms, are naive Bayes, decision tree, and random forest. Now let's talk about regression, which is a numeric prediction. What we haven't covered in supervised machine learning in the course was a numeric problem. In this type, instead of classifying an observation into a group, the computer will return a number, which is a continuous value. Let's say we want to invest in advertisements. So we have 3 options. We can invest in TV, radio, and newspaper ads. We can use machine learning to help us distribute our investment into those 3 kinds of ads. So the computer could tell us, for instance, for a $10 investment, if we invest $5 in TV ads, $3 in radio ads, and $2 in newspaper ads, we will make $12 in sales. For $7 in TV ads, $1 in radio ads, and $2 in newspaper ads, we could make $14 in sales. This one is actually a famous example in machine learning using the advertising dataset, which is shown in this book. This book uses R, which is a language different from Python, but you can find online many applications with the advertising dataset in Python if you want to practice. As you can see, I can search in Google, and in this website, I have an example of how to use the advertising dataset in Python. So you can explore more on this subject if you want. A few common statistical models for this kind of problem are linear regression, SVM, which stands for Support Vector Machine, lasso regression, and a few others. So here's a scheme that summarizes what I've just said. So we have two types of machine learning, which are supervised and unsupervised machine learning. In supervised machine learning, we have the answers, we have the target groups, and in unsupervised machine learning, we don't have answers, we just have the data. In the first type, we have classification and regression problems. In classification, we will classify new observations into a given group. In regression problems, we are looking for a numeric value. In unsupervised machine learning, we can do clustering, which will divide our data into groups, and we can do association, which is going to look for common actions or behaviors in our data. For classification problems, the most popular algorithms or statistical models are KNN, logistic regression, naive Bayes, decision tree, and random forest. For regression problems, we can use linear regression, SVM, lasso regression, and a few others. For clustering, the most popular algorithms are k-means, affinity propagation, optics, spectral clustering, BIRCH, and dbScan. And for association, we can mention a priori, ECLAT, and FP growth. Now, before we finish, let's talk about some good books to power up your knowledge in machine learning. I've just mentioned this one. This is probably the most famous book in the field. Springer is a very reliable book publisher, so when you see something published by Springer, there are high chances of it being an excellent material, so you can trust this book. The downside is that all examples from this book use R, which is a language different from Python. But to learn different statistical models through practical examples, this is a very good choice. If you want a good practical book that uses Python, I would suggest this one published by O'Reilly called Introduction to Machine Learning with Python. For tech subjects like programming languages, web development, data science, O'Reilly is one of the best book publishers out there. I love all their books, they're easy to understand, they start with simple examples and make them more and more complex as you move forward. I learned many programming languages from their books, so I'm sure you won't regret buying this book. They also have other interesting books for learning Python, like Learning Python and Programming Python. Now let me show you another great resource for boosting your skills in machine learning. This website is called Kaggle.com, and this is a large community for machine learning. So here you can find data sets, you can find example notebooks you can download, there are competitions. This is really cool. So here if I go to data sets, as you can see, you have more than 35,000 data sets you can download and apply machine learning. There are courses you can take. You can download notebooks to use in Jupyter. You can even join competitions, and as you can see, there are high prices. So we have competitions where you can win $50,000. So this is your opportunity to make a huge impact using your machine learning skills. And why not make some money with it? So I encourage you to explore Kaggle a little more. So that's it for this video. I hope I was able to get you started with machine learning and provide you the tools you need to move on by yourself and keep learning. Thanks again for being with me, and I'll see you next time.